My name is Kevin. You just probably saw me at the panel. I am a Iceberg committer and an open source contributor. I currently work at Microsoft OneLake as a software engineer on Iceberg and OSS. So this talk is primarily from an open source perspective. It's about Iceberg tables kind of out in the wild in production settings. And I want to go through and show a few examples of interoperability, right? Which is like a big value prop for Iceberg tables. Let's go. I only have 25 minutes. Okay, so I used to work at Stripe. That's the only thing that's missing. Okay, so as I mentioned before, everyone has seen this picture. It's very popular. Shows you the metadata structure of the Iceberg table. Every talk has one of these. The thing I want to talk about today is forget everything you know about the details of Iceberg. We're going to take a step back, and we're going to think about Iceberg table as a whole, right? How am I as a user or as a, let's say, infrastructure engineer working with Iceberg in general, right? This can be one particular Iceberg table or a group of Iceberg table, but mainly we're focused on usage and consumption. So don't think about any of the details. Just think about Iceberg as a black box. So I want to start with kind of level setting, right? If you understand like traditional database systems, it usually is an engine, and inside that engine there's a catalog, right? It keeps track of what is in that engine, and there's also storage, right? It keeps track of the tables, the layout, the metadata. If you take, for example, Postgres, right? It has its own implementation of what a catalog is. It has its own implementation of what a storage is. And its layout, its metadata, it's all encapsulated in that engine itself. And that is true for any other engines, right? Oracle, Snowflake, that's just kind of traditionally what databases are. Oh, missed a slide. And the Iceberg-centric view is we flip this around, right? We say Iceberg, the table format, is the definition for both the metadata and an access. The data itself is stored in Parquet format, right? And the data is on object store. That's like the most simple deployment, right? Most common deployment. And then on top of that, you have the Iceberg catalog, which provides a layer of abstraction to show people where your tables are, right? And through this Iceberg catalog is how engines interact with Iceberg, right? Your Spark, your Trino, your Flink, your DuckDB, Snowflake, Oracle. I think everyone's adding Iceberg support, right? And mainly they're doing it through the catalog layer because that's just how the integration happens. And what I want to discuss over here is that when you think about a traditional database, right, and you think about it in terms of interoperability, what does it take for Postgres to talk to Oracle, to talk to Snowflake, to talk to your favorite vendor or engine, right? Usually the most base common layer is you take the data and you stream the data, right? You take data from place A and put it in place B, right? This is usually, duplication. You move your data, you copy it over from A to B, right? And not only do you have to do that from one engine to another, you have to do from one engine to all the other engines and that engine to everything else, which is why I have this slides for it's a communication problem, right? For any engine to talk to another engine, they need to create a integration point, a specific, very particular integration point for them to talk to each other, right? Which means it's hard to do anything easily because you need to figure out how to communicate, figure out all the nuances between place A and place B. And we don't have that in the Iceberg view, right? With the Iceberg view, what you do is you say, there is a catalog, go integrate with it. And Iceberg and Iceberg catalog introduces standards, right? We just talked about the v3 spec. There's also a Iceberg REST catalog specification, right? And what this introduces is a standard and a reference for integration, right? Your favorite engine doesn't need to go and talk to another engine to say, hey, how are you reading Iceberg and how are you reading Iceberg REST catalog, right? It goes to iceberg.apache.org. It goes to the specification, I hope. and figure out, okay, here's how I access this table. Here's how I interact with this table, right? So there's a common ground, there's a commonality, there's a standard, and there's no communication overhead, right? Because for one engine to talk to Iceberg is the same as for another engine to talk to Iceberg. And along with that, Iceberg community itself also provides libraries, functions in different languages for those integration points, right? If you're in the Java world, if you have a Java engine, you can use the Java library to bring all the Iceberg functionalities. If you're in Python, you can do the same. If you're in Rust, Go, C++ is the newest one, you can do all of that just from using the community libraries, right? And the libraries itself needs to mature and everything, but at the end of the day, there's a commonality and there's a common theme, and there's no communication overhead when you need to integrate. And yeah, just to make my point, the specs are all publicly available. Just go to a website, you can re-implement it. We try our best to make it as clear as possible. And whenever there's a new implementation, sometimes we find differences or modifications or clarifications, and we try to add it to the spec. So here's a little prediction. I like to do this so I can come back and watch it a couple months later. There will be a lot of Iceberg products in the next 12 months. You're already seeing it. I think the marketing got ahead of the product and the maturity of the project. But what you're going to see is kind of a snowball effect, right? A lot of people are integrating with Iceberg, which means they're generating a lot of Iceberg tables, and everyone else wants to tap into that market and come into the ecosystem, so they'll generate more integrations and then more Iceberg tables, and eventually you have, like, hopefully a world of Iceberg tables that everyone can read, right? And this comes because of how easily accessible the specification is, the implementation, the open source libraries, the fact that they're in multiple languages. I'm just speeding through this, right? And over here, I want to take a moment to talk about the value for Iceberg, right? Which is, you put it once on the object store, you say, here is where my table is, and hopefully you go to your favorite engine and say, here is the common integration point, go read and write my table, right? You already see that with Spark, with Trino, with DuckDB, who just added support to it, and you're going to see more and more of that coming through. Okay, we're going to take a step back. Talk about, as a company, you own a lot of data, right? We call it the data estate. You have a lot of data. It's somewhere in there. Depending on your size, it could be really messy. Usually it's messy. It's just how messy. The traditional deployment for Iceberg is, I have an S3 table, right? I have an S3 bucket where I put my data. I have a catalog of some sort. I can use, if I'm, a decade-year-old company, I have a Hive Metastore deployed in my infrastructure somewhere, right? And I have an engine to interact with that data, right? It can be Trino, it can be Spark, it can be whatever. But this is your typical deploy, right? You have an engine that talks to a catalog, that talks to an object store, and everything's fine because you're just talking to one thing, right? But what if, as your company grows, as your product grows, as you acquire more companies, you're going to bring in more and more data, right? So it's not realistic to say I just have one bucket, right? Then, well, in a nice world, okay, I'm on AWS, I have a lot of buckets, right? I have many, many buckets, but still, it's fine because the buckets are just storing the data. It's still in my Hive Metastore. I'm still using the same engine. Great, right? It's a little complicated, but it's not that complicated. Okay, well, now you're getting into a realm of like, okay, I have some data over here, some data over there, and let's say you're still using AWS. You're still using the same cloud provider. Well, I have a Hive Metastore that's operated by this team. I have a AWS Glue that's operated by this team, and I have a Unity catalog that's operated by someone else who just bought that, right? Or you can run it open source, but I'm using it through the same engine, right? And engines like Trino and Spark have been through this transition and can handle this use case. Trino is famously known for having be able to have multiple catalogs. And this looks a little messy already, right? I have a single engine, many catalogs, God knows how many object stores, right? But what if, let's just get crazy, right? I have a lot of S3 buckets. I'm in a multi-cloud environment. I actually have an ADLS container and a GCS bucket, right? If you're a conglomerate, this is pretty much all you have, right? Like you have Hive Metastore from on-prem, you have a Glue using AWS, you have Unity catalog, maybe you have a REST catalog in there, who knows? And you have a lot of engines, right? Everyone wants to use their favorite engines. And you look at this and you go, okay, that's a lot. As a data engineer, as an infrastructure engineer, as someone who has to deal with this every day, what do I do, right? I have to make sure my Hive Metastore integrate with every engine. I have to make sure that every object store can integrate with that Hive Metastore, and I have to do the same thing end to the end, right? I don't know if that's the right permutation, but it's a lot. And then on the engine side, every engine has to support every catalog and every object store, right? And this is where I'm going. It's a communication overhead again, right? Every engine needs to talk to every catalog implementation, needs to talk to every cloud. And as an infrastructure engineer, you're on the hook to do this, right? And maybe your engine, like DuckDB, I don't think has a Hive Metastore implementation. Maybe it does. But if you want to use DuckDB and there's no Hive Metastore implementation, what do? Well, maybe you just say, I don't use it, right? And then you have a matrix of like, this engine only works in these specific scenarios. And that's okay, you can get by, but there's a better way to do this, right? And one of the things I want to mention here is, this pattern is very common, and what you get out of this is, you have a lot of data everywhere, right? And it becomes really, 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 really messy to figure out where your data is, right? My marketing data might be in Hive Metastore on-prem and, I don't know, an on-prem object store provider, right? And my sales data might be on AWS somewhere with the Glue and whatever. I can all look at it from a single engine, but that's going to be really tough to figure out which path to go, right? It's like choose your own adventure, and maybe you write some docs somewhere, and it's going to be outdated. So you end up with a lot of data puddles. That's a pun, right? Like there's a lot of data everywhere. You're trying to keep track of them and make sure they're all connected to your engine so you can use it. I think the point is, it's still an abstraction problem, right? Like when you look at all of the components, you're looking at like a physical representation of where your table is. My Iceberg table is on Hive Metastore and in S3, right? And that level of thinking works when you're dealing with very, very few tables. And as it explodes, it is very, very difficult to understand, right? And you can have physical locations, but really there's only one logical representation. Your sales table is a sales table. It doesn't matter where the underlying table is or where the underlying catalog implementation is, right? If I want to access my sales table, just give me the data, right? I don't need to worry about what catalog I'm using. I don't need to worry about which cloud. I don't need to worry about which bucket. There must be a better way. Okay, so let's take a step back, right? Let's look at the big picture. Maybe there's too many engines, right? Let's just chop down the number of engines and maybe keep like 3. I would argue that it's good to have many engines because engines are specific to their use case, right? So let's not make it the engine's problem. Let's just say the whole purpose of using Iceberg table is for all the engines to be able to interact with it. Let's go a level down. Well, there are too many catalogs, right? I have maybe a Hive Metastore somewhere, and I'm saying this again and again, right? And this is, I have a Substack that I wrote, and I stopped writing, but this is from 2024, right? I was an infrastructure engineer at Stripe. We were running Hive Metastore. We're running multiple Hive Metastores, and we're running on Iceberg, and we're trying to figure out what to do. And the Iceberg REST catalog is part of the solution here, right? Why is it the solution? If you look at it from a REST catalog perspective, everyone knows what that is, right? Like it's just HTTP over like catalog, right? Give me a table, update a table. All your engines knows how to interact with the Iceberg REST catalog. Why? Because it's an open standard, it's a specification out there. For an engine, if you look at Trino, I mean, Trino's a bad example because they've been around for a while. But if Trino has to be re-implemented right now, they would rather implement one catalog implementation than all of the ones that they support, right? They support Glue, they support Hive Metastore. For each of those, it's extra integration point that they have to do just to talk to a catalog implementation to get what a table is at the end of the day, right? So IRC is just an interface, right? It's over HTTP. Everyone knows how to do HTTP. You can do that in any languages. And ultimately, IRC is backed by another catalog because you're storing the information somewhere, right? Not only can it be backed by a single catalog, you're behind a server. You can do as many catalogs as you want, right? You can use it as a proxy to say, my 30 catalogs that I have across my data estate can all be in a single REST catalog interface, and I can deduplicate there, right? I have a single interface that I can ask, where is this table, right? And it's up to the catalog server to go figure out, okay, this is where that table is, right? And you kind of decouple what the engine needs to implement and what the catalog needs to return, right? And at the end of the day, tables are just stored in the catalog as a pointer, right? The catalog just say, here's where your table is, right? Your facts.dim. Whatever table is in this S3 bucket somewhere. So this is what I'm proposing, right? Is that every engine just talks to the REST catalog, and you don't need to worry about what catalog implementations are there, right? As an infrastructure engineer, what you're doing is abstracting away that catalog concept through HTTP and putting everything behind a server, right? So then you just connect all your catalogs to Iceberg REST and let your engine just talk to that one, right? Simplifies the integration. Okay. Another problem here is there's too many object stores. And this can be like, I'm across many clouds, or maybe if I just have like 100 buckets, right, or 1,000 buckets. I think there's a limit for AWS. It's a high limit, but I'm sure people run into that a lot. And it's hard to figure out which bucket is for which table. Well, I will argue that instead of looking at a specific bucket, you just look at everything as tables, right? They're not objects on a bucket, they're just tables, right? Iceberg lets you to abstract all of that away where it's physically located, where the storage is physically located, and you can just look at it from here's how I'm operating this table through my catalog. Okay, so all of this is to say, I think there's going to be a lot of kind of catalog-centric view in the Iceberg world in order to facilitate with the abstractions and with the integrations between engines, between the object stores, and just make sure that as end users, you don't have to think about a lot of this. Speeding through it. Okay, so here's where I'm trying to talk about what we just mentioned from a kind of what we did. I work at OneLake, by the way, at Microsoft. I want to give an example of, here's why we did this, right? Here's why we launched what's called a table API, which is a Iceberg REST catalog implementation. And this isn't special. I think anyone can do this, right? Iceberg REST catalog is out there. The specification is out there. There's a reference implementation on the open source library. You can run this on your Docker, on your laptop right now, and it just works. It's the matter of abstraction and how you are showing that to your end users. So let's go through an example, right? For those who don't know, OneLake, Microsoft OneLake, is a product. It's a single unified data lake, which means instead of having data puddles, your organization has just one lake, right? It's a single logical unified representation of all your data. It's hard to figure out because usually you deal with buckets. But no, this is just, you're one organization, you're on Microsoft Fabric, you get one lake. That's all you get, right? It's one and only one giant data lake. From that, what we did is we slapped a table API on top. We say, there is a single unified Iceberg REST catalog compliant catalog implementation that gets you where your data is, right? All of the tables are just a single unified logical representation of the table, right? OneLake itself can be thought of as like object store. The table API is how you interact with the object store to get tables back, right? I don't want to think about my objects, my bytes. I want to think about tables, Iceberg tables. And it just works, right? By implementing the Iceberg REST catalog and exposing it, what I've done is I've integrated this platform into all of the engines without talking to them, right? Trino already works with Iceberg REST catalog. DuckDB already works with Iceberg REST catalog. PyIceberg, everyone on the engine side, all they need to do is to understand how to interact with the Iceberg REST catalog, and everyone on the other side just needs to provide the right abstractions and the right response back in order to interact with them. Again, no more communication problems. And it works across vendors too. If I have time, I can show this, but Snowflake itself has a catalog link database feature where they take an Iceberg REST catalog endpoint, and you can take that, give it a Snowflake, and they understand and they can read your data, right? And it could work across cloud, although this one is, I would put a little caveat because sometimes just because you can doesn't mean you want to. Cross cloud is very expensive, but there are ways if you really want to, right? There are ways of doing it, right? OneLake has a product called Shortcuts. You can say, I'm on Microsoft, but my data is in S3, and you just as your desktop shortcut over, right? But this is getting a little complicated, so I want to skip that. And I have 4 minutes? Okay, so let's see, how do I show this? This is Spark, yeah? The bearer token's already expired, but don't need to copy that. But this is what we're doing, right? We say Spark already integrated with Iceberg REST catalog. All we're doing is filling out some form as part of Spark. You don't have to pull in any additional libraries, right? It just works. You go out to reach into this HTTP endpoint. You have the bearer token, so we allow you to do it. And all you get back is representations of table, and now you can use Spark, right? Same thing, PyIceberg, everyone is integrated with Iceberg REST catalog. You provide the endpoint, you provide a key, we let you read your tables, right? And these are all standard integration. DuckDB added it, very similar. It works, I can show that it works. I'm running out of time. And then I have one last one, which is the Snowflake's catalog link database that I want to talk about. Right? Inside Snowflake, I provide one catalog URL that's highlighted right here. And all of a sudden, Snowflake knows how to read data from OneLake. And we didn't talk to each other about that. Right? There's no custom integration. Everything goes through IRC. Right? OK, I'm done. Questions?
Questions? Raise your hand.
I think I have one. Time for one question.
1 minute. Yep. OK, cool. I'll come right over. But yes, we have time for one question.
Hi. Can we use multiple engines to do write operations on an Iceberg table? Let's say the regular data ingestion goes through one engine, while I perform the compaction and expiry cleanup through a separate engine.
Yeah. Yes, but you have to be careful. I think there's a right. So when you do commit, you have to make sure you're doing it the right way, right? When you do compaction, it's as if you're doing another write, right? It's as if you're taking the what you have as a table and rewriting it, right? Somehow, even if you're rewriting the structure, this is traditionally the job of a catalog in the catalog implementation. Make sure that your catalog has the capability to do concurrent write. Because otherwise, things will go really poorly, right? The catalog has to maintain the consistency of your data updates, right? So yes, and what you see in the wild is there are actually many engines that write to the same table, right? You have a real-time one, you have a batch one, and then maybe you have a compaction or maintenance on the side, right? So everything interact with this one table It's the catalog's job, right?
Perfect. A
Thank
big
you.
round of applause for Kevin Liu of Microsoft. Woo!